Alright, welcome to the third video in unit number 6 where we're talking about kinetic energy. So today, kinetic energy. What determines how much kinetic energy an object has? Two things only, nothing more than this. As one would expect initially, certainly if kinetic energy is, the energy of motion, it depends on the object, which is its mass and its speed. Now we specify speed for a reason. We know energy has to be a scalar, so we have to be multiplying scalars, not vectors. So we have to use speed, not mass. So direction doesn't matter for energy, for kinetic energy. So how can change kinetic energy must be done. If we think about our relationship of energy before, where we had change in energy, well, if we just think of that as just the change in kinetic energy, then it's work. So in other words, what must be done is work. Now, here's EK. We have to know what EK is before we can calculate it. So EK, kinetic energy, is 1/2 mv squared. So m is our mass, and that's in kilograms, and v is speed in meters per second, and that gives us our energy, and units for energy are always going to be the same, which is going to be a joule, capital J. So let's take a look at an example. A skater with a mass of 52 kilograms was moving at 2.5 meters to glide to a stop over a distance of 24.0 meters. How much did the friction of the ice do to bring the skater to a stop? And how much work would the skater have to do to speed up to 2.5 meters per second again? So if we write out what we know. Alright, so here's what we know, and let's just, start with our equation. So we're looking for work. If we're not given anything about forces, we have to use our other relationship that we've got the change in energy, and we'll use specifically our kinetic energy. So changing kinetic energy, we have to think about that being EK minus EK0. And so we get 1/2 mv squared minus 1/2 mv naught squared. Now we've got m, we've got v, we got m, and we got v naught. So we can calculate this right away. And so plug everything in. 52.0 kilograms times 0 meters per second minus 1/2 times 52.0 kilograms times 2.5 meters per second squared. Number one thing that everybody's going to forget to do is square it in your calculations, and you get a final answer of 160 joules. So there you go. It's as simple as that. You've calculated the work done by friction. We would expect it to be negative because it's in the opposite direction to the direction we're going. So that's good. So everything works out. Now, that's only for part A of the question. What about part B, where we're asked how much work would the skater have to do to speed up to the same speed? Well, if we think about it, the only things that are going to change is V naught will become V and V will become V naught. So those two things are going to switch, which just means that we're going to have, instead of 0 minus 160, we're going to have 160 minus 0. So the distance, even though we're given it, does not matter. And so here we are. We get left with work for part B would just be the positive version, because that would be how much work you have to do in that direction to speed up again. So we would get 160 joules. You can calculate that out, or you can write out some sort of statement about why that is true. Either way, totally acceptable way to answer it. So let's take a look at our other example here. So we've got an 875 kilogram compact car, speeds up from 22.0 meters per second to 44.0 meters per second while passing another car. What are its final energy, initial energy, final energy, and how much work is done on the car to increase its speed? So let's write out what we know. So we've got what we know. We got the mass, the initial speed, the final speed. We're looking for the initial kinetic energy, the final kinetic energy, and the work done. So, let's just, again, start with your equation. See if you have what you know. So we need 1/2 mv0 squared for EK0, or, our initial kinetic energy, which we have all that, so we can calculate that. 875.0 kilograms times 22.0 meters per second squared. Now, don't forget to square it in your calculation, and you're going to get 2.12 times 10 to the power 5 joules. Now, do the same thing again, 1/2 mv squared, and you're going to get, hopefully you should expect to get in the same range of value. And if you're not, then, go back again, make sure you're squaring, make sure you're doing everything, solving it properly, and you get 8.47 times 10 to the 5 joules. And the last thing that we're asked to solve for is the work. So again, we're not dealing with forces in this question, so think about our other relationships with work. Work is our change in energy. In this case, we'll talk about the change in kinetic energy, because that's what we're focusing on. And so that would be EK minus EK0, which we have those two numbers there. And if you subtracted them, you would get 6.35 times 10 to the power 5 joules. And there's our 3 answers to this question. Again, start with your equation, see where it leads you, write your givens, and just follow it out. Try those questions, and as always, physics is awesome.